Hey everyone, today we're going to discuss about the rules of inferences. So these rules are also used whenever we prove statements. Unlike with the rules of equivalence where the one statement is equivalent to another one, this rule of inference this means that if we have two statements or one statement, it means that we can infer another true statement from a given statement or statements. So we are trying to infer that this statement is true because we know that some previous statements are also true. In this, because of this, the rules of inferences doesn't work the other way around. Unlike with the equivalent, it works both ways. This one, it doesn't work the other way around. It only works from antecedent to consequence only. So our first rule is the modus ponens. The modus ponens has two statements, P implies Q and P. If these statements are true, then it means that we can infer that Q is true. So that's modus ponens. P implies Q is true and is true, therefore Q is true. For the modus tollens, we have two statements again. P implies Q is true and not Q is true. If this is true, then this means that not P is true. So we can infer that not P is true because of these two statements according to the modus tollens. For the third rule, we have the conjunctive simplification. So the conjunctive simplification makes use of the operation AND, P and Q. So we can simplify P and Q by removing one of its statements. So if P and Q is true, it means that P is true and Q is true as well. So we can separate the conjunction. For the disjunctive simplification, we make use of the operation OR. If we know that P or Q is true, and P or not Q is true, then it doesn't matter what the value of Q or not Q is. It remains true, regardless if Q is true or if Q is false. This means that P is true. That's for disjunctive simplification. So, yeah. For number 5, we have let's observe that in simplification we are trying to simplify a statement into a single statement. So P and Q becomes P or becomes Q, while these statements simplifies to become P. For the next one, we have the addition statements. So we can add statements using either the conjunctive addition and the disjunctive addition. For the conjunctive addition, we have this one. If we know that P is true, and we also know that Q is true, then we can combine the two statements as P and Q. And this P and Q remains true since we know that P is true and Q is true. We can add it using conjunctive addition. For the disjunctive addition, we only need to know that P is true so that we can write as P or Q. It doesn't matter if Q is true or false, since we know that P or Q is true since P is true. Remember, for disjunction, only one needs to be true. So it doesn't necessarily mean that we have to know whether Q is true or false. For the next one, we have the syllogisms. So we have the disjunctive syllogism. P or Q is true and not Q is true. If this is the case, then we can say that P is true. So but this means that if not Q is true, then it means that Q is false. But we know that P or Q is true. So if Q is false, then it follows that P is true. For the hypothetical syllogism, we can think of it like a transitive property. P implies Q and Q implies R. If this is the case, then P implies R. So it's like a transitive property. For our last rule, we have the dilemmas. So the constructive dilemma is just an extension of the modus ponens. We have three statements here. Wait, I forgot to fix this one. Let me fix this first. There. For the constructive dilemma, we have two conditional statements. P implies Q and R implies S. Then we have one disjunction here, P or R, which we know is true. If this is the case, we can say that Q or S is true, since this implies that We have two conditional statements, and we are saying that at least one of them is true. One of the antecedents is true. So this means that one of the consequences would also be true, Q or S. That's a constructive dilemma. For the destructive dilemma, this is just an extension of the modus tollens. We still have P implies Q and R implies S. And not Q or not S is true. So this means that either one of the consequences are false. If either one of the consequences are false, then it means that either one of the antecedents are also false. So this means that not P or not R is true. So that's the rules of inference that we can use for proving. Let's have an example. So for example here, we have example. Our statement is given A, that is A and B implies not C. Next is we have D implies C. Next is A and next is B. So we know that these four statements are true. A and B implies not C is true. D implies C is true. A is true. B is true. What we'd like to prove is that D is also true. So let's use a two-column proof in order for us to show that. So let's have this one. This is the statement part. This is the reasons part. Statements, reason. So let's have first our given here, A, B, C, D. So this is the given. So that is 1A, 1B, 1C, and 1D. So for our statement 2, let's start by approaching D here. We know that on statement B, we can see D implies C. So we should be able to arrive here if we somehow can prove that, by the way, there's a correction here. This should be a not D, rather. Yeah. So we should be able to arrive on a not D if somehow we can show that not C is true using the modus tollens. And we can get a not C here by having A and B implies not C. Oh, so if somehow we can arrive at A and B, we can use modus ponens to get not C. Then we can use not C to get not D using modus tollens. Do you follow that? So let's start first by getting an A and B. So we know that on C, we have statement A is true and statement B is true. So we can say that on statement 2, A and B is true using 1C, 1D, conjunctive addition. Remember that in conjunctive addition, we can add two true statements together to form a conjunction, A and B, since A is true and B is true. Since we know that A and B is true, this is A and B, diba? And this is A and B. So if A and B is true, it follows that not C is true. So if not C is true, we base it from statements 1A and statement 2. So that is 1A, 2. That is modus ponens. Modus ponens states that if we have a conditional statement and the antecedent is true, then the consequent is true. For the next one, since we know that not C is true, then we know that C is false. If C is false, then it follows that D is false. So we can say that not D is true since we know that C is true. So we're going to reverse it from 1B. So we used 1B and 3. 1B, D implies C, and 3 is not C. If not C is true, then not D is also true. So that is from modus tollens. So that's our statement that we're going to use, since we have 1B right here and 3 is not C. So we're just going to reverse it. Now that we arrive at not C, we've shown that not C is a true statement. So we're going to have our tombstone here to indicate that we are done. So that's it for our for proofing statements using the rules of inferences. So you have to memorize all the rules of equivalences and rules of inferences so that we have a grasp on how are we going to prove statements, and we have to understand what they imply and what they show. So I hope you guys learned a lot today. Thank you guys for watching, and see you guys in the next video.